Let's have some fun using mathematical theories today, right? So I'm going to prove it to you that 1 is equal to 2. You're not going to believe that, right? Let's see. Here I am going to assume that A is equal to B, right? So from here onwards, what I'm going to do is I'm going to use mathematical theories. You know that if I multiply this side by B, I have to do the same thing to the other side. So let's do it. B into B, so that AB become equal to B square, isn't it? Right. So up to here it is correct, isn't it? Right. So what I'm going to do now is I am going to subtract the same amount from both sides. AB minus A squared. I am going to subtract A squared from this side. So do the same thing to the other side. You know that, isn't it? Right. So this is the expression that I have got. And as students, I know that you are familiar with factorizing. Can you see? We have a common factor here. So let's take it out. A is common, which means inside the bracket we have B minus A. And you are familiar with this one, isn't it? What is this? Difference between two squares. Yes. So we can write it as B minus A and B plus A. Now, can you see? B minus A is common, which means I can divide this side by B minus A and I have to do the same thing to the other side and it will be B minus A. Now what happens? Yes, you can cut them, they get cancelled and my A value become equal to B plus A. But from my earlier assumption, I know that A is equal to B, which means what I have here is B. Instead of that, I can write A. So what I have here is A plus A, which is equal to A, which means A should be equal to 2A. Isn't this wonderful? Right? I am going to divide this side by A, this side by A. What happens even if I divide A by A? Yes, it become 1 and they get cancelled and it become 2. 1 is equal to 2. Can it be? No, it can't be. There is something wrong here. Let me know what went wrong here, right? That's your challenge.